Hey everybody, this is Larry. This is me doing, it's June 18th. There's no, I'm a little bit early today on Daily Problem, but the reason I'm doing the bonus extra, let's call it random prompt for today, is actually, let's do the other one. Sorry. It's not that I'm picking, but I want to pick a slightly harder one. Um, yeah, is that I'm going to do a hard prompt today, is because not gonna lie, it is 87, 90 degrees, something like this, 90 F to Celsius, which is 32 degrees Celsius here in New York. I am gonna go for an hour run later, but I figured I always complain about being dead tired afterwards, so today at least I'll do a hard prompt before going for that run. So the daily prompt doesn't come out yet, otherwise. So yeah, that'll just come out when it comes out. Anyway, today's problem is 2941, maximum GCD-Sum of a subarray. You're given an array of integer nums and an integer k. The GCD-Sum of an array A is calculated as follows. Let S be the sum of all elements of A. Let G be the greatest common divisor of all elements of A. The GCD-Sum of A is equal to S times G. Okay, let me reread this. S is the sum. Okay, so you have an array. S is the sum of the elements. G is the GCD of all the elements. So then GCD-Sum is going to be S times G. So this, the sum, I guess it's going to be some number. And then the G is going to be GCD, right? And then okay. So the first thing to notice, I am leaning towards some sort of almost like a BFS, or maybe not BFS, but what you would call it, a union find type solution. Because because the thing is that as you add more and more number, the GCD will only go down, and I'm thinking about some sort of I don't know about greedy, but some sort of way that kind of merges it together, right? Because the thing is that when you merge two components, the GCD will be merged. Greatest common, yeah, the GCD will be merged and it will go down. But I don't know. I don't know if you could do it greedy. I think that's the problem. I'm trying to think. I mean, that's certainly an idea. I'm trying to think whether there's a way to do it in a greedy kind of way, right? Or like, I mean, there's a way to do it greedy. The question is whether greedy will be the solution, right? Or like it's or the proof for greedy. I think is maybe a way to phrase it. So I'm like in the middle of trying to also think about it in general, but yeah, for example, if you go 9, is it okay? I think it's okay to be greedy in a sense because is it though? So let's say you have, I don't know, 2, 10, and 5, right? Here you definitely want to merge to the right first, but is there a way that we can, yeah, because if this is, say, I don't know, power of 216, or even like just huge power to 128, here the GCD is going to be 2, but the sum is going to be bigger. So it's not clear to me that I can do greedy in this way, because this is a counterexample, right? If here you go GCD, bigger GCD first, then you would go with the 5, and this would be good. But of course, if this is the counter example for bigger GCD first, because 10 and 5 would have the better GCD, but 10 and this other thing would have a bigger GCD sum, right? And here you want the smaller GCD first or something, right? Well, I did forget to look at constraints, because that would be really silly if it's just like an n square solution. But I'm glad that it's not, because then I'm just wasting my time. Also, it wouldn't be a hard though, because you would just do 2 for loops. But 10 to the 6 is interesting. Maybe we can use if for this, or this part of it. But I don't even think that matters that much. Can we do binary search? So the thing with GCD is that, let's say we start at a certain index, right? Let's say we start at 9. Also, just to be clear, it's clear that I don't know the answer. But anyway, we start at 9, and then it's just going to, the GCD goes down as you add more elements, but the sum goes up. Obviously, maybe. So that's a tricky balance then, right? So then, can we do a ternary search? Because basically the idea is that you have 2 functions, right? You have a g function. Let's say this is starting at a certain index, and then times sum of x, or whatever, right? The sum function, right? The GC, this is going to be monotonically decreasing, and this is going to be monotonically increasing. So you can think about this curve as like a parabola, right? So that means, and as a parabola, that means that you could do a ternary search, because this is at worst going to be a second ordered function, right? And then but then the question is, okay, let's say we are able to do a ternary search, then how do we do it in log n time? Then we can, because if we could do it in log n time, then we could do it for each index. The sum part, I think, is pretty straightforward. It is whatchamacallit. It is prefix sum or whatever. Yeah, there are a number of ways of doing it. The GCD though, that part is a little bit tricky. I mean, you could do it with a segment tree, but then that's going to make it O of log n, which for this is probably already too slow, especially if you have a segment tree log n. Segment tree has a relatively big constant. So 10 to the 5th, 100,000 log n log square n is going to be too slow. So we need, so even if we are able to do ternary search, we have to be able to do the GCD in a smaller, or in a faster complexity. The other thing, of course, maybe that if there's a way that we can prove sliding window. How would sliding window work? You would slide to the right, and then when do you slide to the left? Well, I mean, Also try to think whether there's like if we are able to sort the GCDs in a way such that, you know, then we can just do the biggest sum, but I don't know if that makes sense. I mean, can we do it backwards, for example? Like here, we can say that the GCD will be, well, this one's easier, but, and oh, I forgot about the K even, right? The K is even trickier. Definitely for, The thing with this function is that it's hard to do sliding windows because if you add or remove element, this function is not monotonically increasing or decreasing, right? This is increasing and this is decreasing, but so together it's I don't think this is a sliding window. It's not like that. Not a naive way of doing it. I think the reverse way that I was trying to think about, and maybe that related to the connected component, is sorting it by almost like in reverse, right? So like here we go, okay, what is the answer of GCD? The G component is 1, and then now what is the component if the GCD is 2, right? But then here, how would you get 2 as the next thing, right? Because 2, then you can just say, okay, then now this divides, and then you just kind of do a sliding thing of, but then if you're not careful, then that could also, well, maybe not a sliding thing then, but you just kind of break apart into 1. So you have to have quick access to kind of, almost like the opposite of joining together in some way, right? But this is a big counterexample of like, if you just kind of join them all together, and then you break them apart by 2s and 5s, the order matters, is my point. Is this a long? Yeah. 10 to the 6 is curious though. I wonder if I can take advantage of it. The Subarray part is the hard part. So I'm thinking about a thing where, like, if I do a sieve and then you kind of sum up all the divisors, but then you still have to connect them together somehow, right? And it's still going to be it's super linear. Well, I don't know. I mean, definitely super linear, but I don't know how super linear. And I don't even know how to factor in K, to be honest. That's the thing. I'm still trying to think for a sliding window, but I still keep on hitting it for the same point, which is that here 7 and 3, it's going to be worse than just 7 or just 3. Well, no, not just 3, but here extending 9 actually makes the 7 case better, but not the. I mean, this is where we have a ternary search. But again, I don't know how to do GCD of a region. I guess we can do square root decomposition with that one, but is that too slow? What is square root of 10 to the 5th again? 316. No, you can't do 300. No, that's 31 million, right? So you can't do square root decomposition. Oh, it's just too slow. At least in Python. Maybe I could do it in another language. I don't know. Even log n is like twice as fast or 3 times as fast, which is even already cutting it, even with ternary search. It was exactly 2, then this would make it easier, kind of, but maybe, I don't know. I don't know how to do range GCD, but maybe we could do a sliding window GCD. I don't know. Can we do a binary search on just G? Okay, if G is 1, then this is huge. G is 2, this is smaller. But the function that we're trying to get is the total function, right? So we can't just given that this is increasing, when does this decrease in a slow enough way? And if we binary search on this, and it's not really a binary search about, right? Because GCD of 2 is not the same as GCD of 3 or whatever, or like, you know, they have different overlapping segments. How many factors? 128 or something? Max. Under a million. Was it 100 million or no? It's 1 million, right? Yeah. Height. I think it's like 128, right? That's what I know. No, I'm wrong. Under a million, 256. Maybe I was thinking of something else. Maybe I was thinking of under 100,000. Because that's 128. So okay. So 256 or 240. 240 is still pretty high though. Because my idea is just do a DP on every factor. Well, let's give it a try. I don't know. I don't know if this is good, but I'm going to give it a try. With dynamic programming and the factor. So maybe index and a factor. Right. Again, I'm not going to go with dynamic programming for this problem just because it's already hard enough as is. And there are plenty of opportunities to kind of do it for other things, right? So if index is equal to n, then we just return 0. Oops. Cannot type. Otherwise, yeah, we have to factorize every number. That's fine. I hate doing SIF in Leetcode because that's why I'm just like thinking about it. Just because there's so much incentive to do it outside the loop, which is kind of like I feel like it's cheating. Like that should not be needed, but we'll see how it goes, right? So f is equal to I think previous, I guess, is do it. something like this, right? I don't know if you give it to something like this, but I don't know, it's fine. There's a lot of optimizations you can do. Yeah. And now current is equal to num sub index, right? So then now how do I want to write it? Oh yeah, so basically if num sub index mod factor is equal to 0, then we can just consider it. Plus, this plus is not quite right, because if you break it apart, also, well, this is definitely not right, but I'm trying to think, how do I even do this? Should be fine. If all the numbers are the same number, it should only do 128 times whatever times n, so it should be okay. Right. Yeah, I think this is a little bit weird, but yeah, and then I think what I want to do is just cache on this, but I think we could probably have memorized this in a different way. I don't know. Right, and then now we do current is equal to num sub I, right? Call I. Okay. Yeah, I think this is more right. Why did I 15? Oh, I'm doing this wrong. This is the thing. This is this times current. Because this just gives you the sum, and then okay. But is this fast enough, right? That's the actual question. Let's just do, for example, let's just do nums is equal to, I don't know, let's just choose a, what was that number that I had? Alright, let's just say this number times 10 to the 5th. Ooh. Is that not big enough? Alright, let's just do 5 for now. Oh yeah, I mean, of course it doesn't fit, but I just want to see if it's fast enough. But this not, why doesn't this work? Do they have to be unique or anything? Less than 1 million? Do I have too many zeros? I don't know. I don't think so. Why is this not a routed input? Alright, let's just do 2 for now and then see if this gives me a weird answer. I don't get it. Is this number wrong? No, this is the sum. Right, so there's just this number, so it's a million times the GCD, which is that. I don't get why this is not valid input, to be honest. Am I misunderstanding the constraints, or it's just Leetcode being silly? Okay, maybe it's just Leetcode being silly. Alright. Let's try a slightly smaller number then. I don't get it. Leetcode is own constraint is wrong. Okay, let's just do under 100,000 then. Maybe I am wrong. Maybe they put in the wrong numbers. I don't know. Okay, but it takes 1.8 seconds is the thing that I was looking for, which is a little bit long, but doable maybe. So we'll just YOLO it. It may be too long to be honest. It's just hard to tell with Leetcode, right? Because you just don't know how they kind of construct it. Looks like it probably will time out, but we'll see if it gives us a interesting. Oh, I'm actually wrong. Why does it take so long to determine this is wrong? Oh, because I think I messed up on 1. Oh, I forgot about the K case. Oh, that's why I did forget about it. Yeah, I mean I did forget about it. That's just, yeah, that was just sloppy. Though I don't know. Expected is 6, which is all of it. Why would I? How can I do 9? Oh, because I did 3 times 3. Okay, yeah. But because K is 2. How do I factor that in? I forgot about the K. So I don't know if this would have been fast enough, but definitely with the K, we cannot add K as a dimension. So, I mean, this is just a lazy way of writing it. I think you, in a greedy kind of way, for each factor, you would want all the numbers anyway, right? So, okay, fine. So, and then you just do the count that way. Yeah, okay, fine. Yeah, I mean, yeah, okay. So then here, the caching just makes it a little bit cleaner, but also it's clear that it's not n squared, right? Because otherwise it would just time out. But okay, I mean, we just have to do it manually, I think. While current is now, you go to on. We do a calculation on it. So maybe what I was seeing is you go to set right, something like this. Well, equal 1 if current not in scene sub I, then we do stuff which is basically what we have here, right? Which is that j is equal to current. Oh no, j is equal to I while j is less than n, and num sub j divided by a factor is equal to 0. Then we have two things, right? We have total num sub j increment, and then afterwards best is equal to max best total times current being the current factor, and then we move current and we update current. But then now we have to factor in k, right? Which is that if j minus I plus 1 is greater than equal to k. That's basically all we have to do. Then now we don't do this anymore. Oh, it's not factor. Factor is current. Okay, still 9. Why? Oh, because this j increments, so it's actually this is the actual count. Alright, let's give us an attempt. Oh, I forgot. This is now n squared. The reason why we were like this is so that we can write scene sub j dot add current. Oh, well, okay. So we didn't time out, but it is wrong anyway. Okay, so the answer, this outputs 4. How do you get 4? Oh, it outputs 4 because it... Well, the short answer is because we don't do 1. Yeah, I don't think I just do 1, but how do I get 4? Let's take a look at what it's running for. But that's an easy fix for the entire array. I think I just don't do it. So, okay. Num sub I. Yeah. So 2, it does 2, but it doesn't do 1 for 2. Because, well, I guess it should be 1. Maybe I could write it this way. I don't know. It's a little bit of a hack. I thought I did that though. I mean, you could also hack it the other way, so I don't think this is that interesting. But we also forgot this, so this would have been wrong anyway. Oh, what? I don't know why I'm getting things wrong. I'm just very that's the thing, right? Is that if these are like real wrong answers, that's fine. But stuff like forgetting this is silly. Missing 1 is very silly. I need to be better. Okay. And now this one, I have one that I don't know how to debug quite. Okay, just want to make sure. Because that should be the base case for 1. So we can actually just skip this. Oops, well, I don't have to write this. But, nums I pass. So okay, so starting here, what is the factor? Let's just also print that out. Oh, 2. That doesn't seem right, only because this number should have done it. So it's missing getting the first number? That's really weird, right? What is the first number? Maybe I have some weird off by 1 somewhere, I don't know. I'm doing the SIF wrong. Because it's just, my SIF is wrong. Why am I so bad today? I was hoping that I could do it this way, but I'm just being very sloppy, to be honest. Okay. Then current is good. The reason why I wrote it this way is because I wanted to... Is this even right? I want to avoid the -1 case, but... Why am I so bad at this stuff? Okay, so it tries this number. Oh, I'm just being dumb. I am not doing all the numbers. I'm doing all the... I mean, I'm not doing the factors. I'm doing all the prime factors. I'm just being dumb. I'm mixing things up in my head. That's why this is so fast. Because I'm not doing all the factors. I'm just doing all the prime factors. Larry. Okay. What would I do then? Not. I mean, I guess. Yeah, I mean, I guess we just don't do the SIF, and we just do something like. No, you can't do square root of it every time, Larry. What are you doing? Okay. The thing is that now you just have to find the factors, right? Fine. All right. Factors is equal to... So now, man, I am so bad. I'm mixing things up in my head. Maybe I don't know. This is just sloppy. All right. I was wondering why, like, I don't know. Am I just rusty? Am I? Alright. This is, I don't know, this is so weird. But now I have to do recursion. Oh, jeez. And I don't even know if this is right? So if this was right, then I'll be like, all right, at least this is right. But I don't even have, it doesn't have to be here. Maybe just like helper here, yeah. That's not right. What am I writing? This is actually very annoying to write. Actually, no, I could write it differently. This is a little bit silly the way I'm writing it. I could do it with, what do we got? Yeah, okay. No, this is right. It's stupid looking, but it's right. I mean, it might not work, but it's right. Now it's right. This is. I still have that? I guess so. I'm in my timeout because I you know, I didn't factor this in, yeah. But I should also double check that I don't have any silly infinite loops like here. And this would be an infinite loop because it doesn't even make sense. Okay. I mean, something is right, which is good, just not the last one. Why not? Tell me why. This is probably not what we expect. Also, we should have multiple numbers. Oh. This should be. There you go. I mean, okay, the other one. I was confused, but now it should time out. I don't know why it has -1 though, so that means something's wrong. See. I think this is off by 1 anyway, but the way that I'm writing it. Still. Why is it giving me negative? What are these keys? Well, that means that this is -1. Oh. I mean, it's close. No. This is this. Okay. But this could be -1, right? Maybe I just can't help it. Two is 1, okay, 1. Still seems like it's missing some numbers in the factors. I apparently do not know how to program. How do I code anything anymore? Some part of this as well. Okay, I think we're right now, except for that I'm missing the number itself, maybe. Okay. But is it fast enough? I'm just like very sloppy today. It's been this way for like 2-3 weeks. Maybe I'm running too much. I mean, it should time out, I think. But at least we're close. We're closer to the truth. Oh, jeez. It should be 128 times n, but it, or whatever it is. But yeah, I mean, it's borderline not fast enough, which is annoying, to be honest. Yeah, we're close, but not close enough. Because this case takes a long time, because we have a lot of factors for a lot of these things. A lot of them are whatever, but I'm wondering, what if I just do like this? How long does that take? So it saves 1 second, so this isn't it. So I have to be the if statement. So once you don't kick it off, it's probably fine, right? So you just have to add it to one place. Maybe the memory is like maybe I would just then here we could write because then now it doesn't ever extend, I think. That's a very minor optimization, I think. This takes away a lot of adding scene stuff. I think this part is still the part that is more expensive. Maybe I'm wrong, maybe I do need it. Oh no, because I guess in the future it looks at the factors. Maybe I'm wrong here then. Or maybe we could use it in reverse. Right, so go. Now we'll just keep it as a set. So then now we have factors, so then now we have flow code. And so I and then now factors sub j remove. Slightly cleaner. Is it faster? Oh no, we want this to be on the next one. Yeah. I don't know that this is that much faster. Yeah, I didn't really suspect it, but a lot of the time is spent on this stuff though, and maybe even this stuff. So we can maybe just do this. For now, I'm in whatever it takes mode for now. Guess it's safest time. Let's give it a quick submit. I'm not confident about it, but I just wanted to, you know, see if we save time on that itself. I guess I could run this case twice, but it just a long time. Yeah, we get another case, so that's kind of good. I'm just curious if we run it twice, we got 4.5 seconds, right? So it doubles, which means that all the work is here and not on here. I mean, it's probably less than double, but still a lot of the work is still here, which I'm not surprised. This is kind of very awkward. I don't know why this is a helper function, actually. I think, well, initially I wanted to write it recursively. I think that's why, but well, I mean, and I think it is going to be f. So yeah, I saved him a second. This is going to be f times whatever, but it's just f is the number of factors, but it's just that it takes so long. This number of factors is 128. I mean, and this constant is terrible. Is this fast enough? Is it a Python thing? I don't feel like I use that much. Like my constants are relatively okay. But alright, let's just give it a YOLO try. Move this to Java, please. Yeah, I'm just gonna give it a YOLO try for seeing if Java mixes a little bit better. Where? Although this should be a long. Why would you get negative index? Oh, because of this thing. Yeah, okay, that makes sense. Still out of bounds? You maybe do all this work and it's still out of bounds? J is less than max, right? Length. Oh, this is just negative index. But why? Oh, because this is because this is dumb. That's why. Okay, still time limit exceeded. Alright, well, does it actually work before time limit exceeded, or is it just okay? So it does actually maybe work. Just that you know, it actually time limits. Okay, so now I would say I have no idea. Definitely gave it an honest try. Let me think, or you know, let me think about it some more. Huh? Maybe I'm missing some weird thing about this. Maybe it's just sliding window and I'm just struggling a lot. take a look at the Java solution real quick, just in case we do anything too funky. It seems like it's pretty okay. Maybe, I don't know. Seems reasonable enough. I don't think it does anything too ridiculously crazy. Unless there's an infinite loop. Is there an infinite loop? There's no, I mean, this place maybe. No, I mean, it works if we just didn't do the long one, right? So, okay. I feel like there's like a greedy proof that I'm not getting. Like we probably already thought about the idea, it's just that we're not, you know, doing the greedy proof. And I'm not convinced about it anyway. But I don't know, I mean, because this factorizes everything, but I guess we don't, in theory, we don't need to factorize everything, right? If we could do range GCD, that would be great. Oh. I am dumb. I am dumb. I think it's ternary search. I forgot about sparse table. Because with a sparse table, you can just do a GCD of 2 regions and stuff. Yeah, with a sparse table, you could do a GCD of 2 regions and stuff, and then you could do a ternary search as a result. Maybe. Alright, let's give it a YOLO try. I don't even know anymore. Okay, so then here we want a sparse table. I'm just going to ask ChatGPT for. Can you give me a GCD sparse table? I could write it, but I'm just today I am. Okay. Oh, this is the GCD sparse table. So this should give it to you an O of 1, which is the critical thing. But I just forgot about it. Okay, so then now we want geez. I hate that. I mean, I was hoping there would be more fundamental about it. We'll see if there is an actual fundamental way about doing it. But I hate using all these advanced data structures. It's just not that interesting. But yeah, okay. So then now we have the GCD of the range, and then now we can, in theory, do a ternary search, right? Let me just make sure that it runs. What? Why would you just do math.gcd? What line is this? 33. Now 21. Okay, and then now for I in range of n, right? So left is equal to I, right is equal to n minus 1. So we want it inclusive, while left is right, something like this. I always just add a little bit margin because I always forget how to do it. The mid 1 is equal to, I always mess up this part, which is actually really bad, minus left. So that's the span. I'm always so bad at ternary search. So you want this divided by 3 plus left. Something like this, right? This would be from, whatever. Good enough. If f of mid 1 is greater than f of mid 2, then we want to maximize. So that means that f2 will shift to the right. So mid 2, else left is equal to mid 1. And then here we just force if, what is it called? Oh yeah, for x in range from left to right, and they'll be within 5, then now you do f of x, right? So best is equal to max best of x, and then that's what we have. And return best. We didn't implement f yet. F is going to be f of x is just equal to return this is a little bit off. It should be from I to mid 1 and I to mid 2. Yeah, okay. And now this is left right in the span. So then sum, we didn't do the prefix sum. I actually forgot about the prefix sum. Okay, so then now so then now we have prefix of right plus 1 minus prefix of left. So that's the prefix sum portion. And then we query the GCD portion, which is g.query left right. I think this is inclusive. Hopefully it is. Where's my other one? Burst. Alright, I mean, we have some wrong answers, but that's okay. Maybe. We also got some right answers, so that's good. Luckily, we have one that is... Oh, I forgot the K. So at least K is going to be... How do I get at least K? Right, so this is going to be I plus K minus 1. And this... And min of this and n minus 1. No, because if it's min, then it just doesn't tick, right? If x minus I plus 1 is greater than k, and x is less than n. Okay, wow, that actually, that was it. Okay. I don't know if it's, this is definitely faster than the other solution, but I don't know if it's fast enough. It's about like 3 times faster. I forgot about sparse table. But, oh, I was going to say, still looks a little bit slow, but maybe it still is, but it doesn't tell you the time. But this is going to be more annoying to debug. It may be just that I'm off by 1 somewhere or something, but which is unfortunate. I mean, the sparse table looks kind of okay. I don't know if this right is inclusive or exclusive. I wish there's a note on this. I guess I'll just ask ChatGPT. It is inclusive. So what am I getting wrong here? Is it this thing? I know that I'm going to get the other cases wrong, but I just want to see what it returns, and it returns way too big. But what if I do something funky like this? Did it go out of bounds? It doesn't go out of bounds, which is actually a little bit concerning. It should go out of bounds is what I was hoping. Maybe that some part of this is wrong as a result. And also, I guess here we can actually do if I plus k minus 1 is greater than equal to n, then we just break, right? I guess that would be easier. Okay, it's still wrong, but with the same answer. Am I off by 1? Maybe I'm just off by 1 on the k. That doesn't seem to change anything. What about here? Maybe I just... This is hard to debug though, because, well, you know. Oh, this isn't a full thing, so maybe I could just do something like a smaller number. So even for one number, this is wrong, which is actually very awkward. It skips this part. It does I is going to be going from I to, if this is 1, then this is just going to be I to I. Okay. Why is this giving me this number? If k is equal to 1, print oh, I mean, are these all even numbers or something? No, so that means that no. Okay, let's just look. We don't have that many numbers. But our number is actually lower than the expected number. Why? So we think that this does it. It should be right. This is just so, I don't even know how to debug this in a good way. Does 2 have a different number? Two already, I reduced it a lot more. We're close, but Not quite. Well, one number, just if the number changed from one number to one, that means that the answer is one, right? So what is this number? Isn't it just this number square? It should be, maybe, if I could copy paste it in a way. I don't know why it's not linked. You just select this, but okay. Okay, so this number is just this square, but it thinks, but the expected number is, I don't know how to get this number, so that's the tricky part. For one number. Okay, fine. Prefix sum plus, okay. Oh no, it's printing way too much. I forgot about the other cases. Alright, let's just get rid of them. Alright. Should be coming up. Alright, it's here. It gives me 1176. Man, I did not print out useful information at all. But now this should be doing, you know, it's doing this. But I don't know. Maybe ternary search is wrong. That's the only thing I can think of, really. So the way that I can show that is the case is if we just do wait, where's my, okay, let's just do, I don't know, let's just say 100, so then that should be the entire way. So if this gives me the right answer, that means that the function is not quite right. So now maybe I can print num sub I, f sub ix, and then maybe it will tell me that it is just wrong. Did I miss the number right? No. Well, I mean, maybe ternary search is wrong then, clearly. I thought it would be right, but... How am I not finding this if this is what it is printing? I don't get it. Oh, it's probably hidden under this thing. Okay. Oh. Okay. Okay, so is ternary search wrong? The answer is okay, so it's increasing. Crazy increase. decrease and then increase. Okay, so ternary search is wrong because as you can see here, I thought it would be right, huh? I mean, I guess the G function is monotonically decreasing, but but not quite well enough, because as you can see, this increases, it decreases, but then it increases again. So this is why our ternary search is giving us wrong answer, which is fine. Well, like, you know, I thought that maybe I had a shot with this here, but okay. I mean, everything else, I just feel like, how did I do this without factorizing? Like, factorizing takes so long, at least the way that I wrote it. And I don't know that there's an easier way to, or quicker way to write it. Because, I mean, because the way that I would change it is just, yeah, but just factorizing takes so long. Oh, I have no idea how to do this one, apparently. Okay, so I mean, this is definitely wrong then. GCD-Sum. What can we do about a GCD? This is such a hard problem, or one that I'm blind to. But apparently this is fast enough, and somehow, also, this only doesn't work after like a ridiculous amount of test cases, which is also ridiculous, but yeah, and the reason is because G is monotonically decreasing, but then sum goes up, so it always goes up if G remains the same. So the curve is always going to do, but then G can go down. So I think another thing that I'm trying to think is like, how do you determine the borders of when GCD changed, right? And I think that might give me an answer, but if we're able to calculate that in a good way, because that's also factor times 228, but then yeah, just knowing the factors seems a little bit much. And I don't know if there's a quick way to determine where all the things are kind of factored together. Excuse me, man, I am tired. Like, now is about when I was hoping to finish this in like 20 minutes or so. It's an hour and a half now, so I'm already a little bit more tired and I need to go for a run soon. But, trying to think. Some part is easy. So that the sum is going to be 1. Still trying to think about it in terms of segments, but there's just so many factors. I'm not going to do factors on, or the sum of the counts of factors. Right? And there's that case with Um, if given G, I don't know. I'm gonna use the bathroom real quick and try to think about this. Yeah, this took way longer than I expected, so I need to use the restroom. But it is just gonna be me thinking anyway. This took way longer than I expected, and so I was okay. Wash my face and kind of clean up a little bit. Okay. Okay. So this is not it, right? What are we doing? What if we do a running count of GCD, which is what I was trying to do, but I think I was looking at all the factors. Maybe all the factors is too much. Maybe we eliminate a little bit quicker, right? So maybe we have 4x and nums, right? And then now, I'm just checking the temperature. It's still very hot outside, so I guess I'll wait a little bit anyway. So let's say we have a previous list of all the GCDs. What does it mean? So it will be bounded by the number of factors, right? So let's just say we have, yeah, let's just say we, I think this is maybe a little bit tighter, something like index and then x, because x by itself is going to be GCD. And then now looking backwards, we for I, P for the, yeah, I guess pre G for previous pre-CT. If GCD of PG and X is equal to PG, then we continue, right? That means that we're still continuing on this thing. Maybe we just have a new G. A new G dot append P I and PG. Why is this in red? Okay, so then, because that means that we continue the thing. Right. And then if index minus I maybe this should be I wanted to handle itself, that's why. But it's so if it doesn't change, it's good. Otherwise, we create a new one, right? Well, +1 maybe. Is greater than K, then best is equal to max best. Sum prefix of index +1 minus prefix of I times PG, else I guess this is just the same thing, right? I'm trying to think about how to write this in a way that if two things merge together, we because then now let's say PG is equal to this, and this would probably be good. But we only, okay, actually let's just see if this works. I mean, I know that this duplicates a lot of work, so this is almost certainly wrong. Or it'll time out on bigger cases. I just want to see if it works. Okay, so it doesn't, well, I mean, it works on a 14. Why doesn't it work on 1? And we do a lot of duplicate work, so I actually expected this to work. Oh, because I don't do the 1 by itself thing. It's a little bit awkward. Okay, well, I mean, that didn't fix it, so I thought that might for 1 element type items. Let's also just print it out real quick. Maybe I need some visualization. Okay, so 0 index. From 0, this is the prefix. Okay. Well, a lot of them should merge together, as you can see, but that's fine. But it should give us at least the right answer, even if it's just a lot of duplicate work, which is why I'm a little bit not understanding this part. This does get increasingly smaller, which is true. I'm missing some weird thing with like weird indexing, maybe? Nope. Why is this wrong? Tell me why. Alright, let's just use the example case for now as well. Maybe I'm just missing some really obvious things. Okay. That's good that this is wrong. I'm giving 36. Why am I giving 36? So 2 is going to be 9. Best prefix I index minus 1 PG. 2 9. 9 should be, is this not 9? It appends to 2 9, so then this part I need this thing here. I mean, again, that's just too much work, but at least it should fix it. Maybe not. Oh no, because this fixes NG, not G. Okay, well, oops. Okay. Oh, okay. That fixes the other wing too. Okay. I guess that's what we needed to do. Okay, so now we have it fixed, but yeah, the thing is that now we're doing too much duplicate work because the prefix thing, right? But we keep this in order, and it looks like we should be able to keep this in order. That means that the PG will be the unique one. So, okay, so then maybe I just have a scene. If PG in scene, then we just continue. Otherwise, scene.add PG. So then we don't do the duplicate work of this part. But more importantly, they're appending it in the future. Okay, this looks good. Give us submit. YOLO. Oh, snaps. This is a very hard problem. I don't know. I mean, I kind of had this. I mean, I had the same idea with the factors, but I think when I was in the bathroom, well, it reminded me of something that happened on my Discord the other day, which is something. What was that one? Like maximum bitwise OR or something like this. And that problem reminded me of like the 30 times n solution, which in this case I think is similar in that they're really I mean, that's what I was trying to do with the factors, but I think the constants were just too big. The way that I'm doing now, it seems like, I mean, I'm trying to. I guess calculating the factors is one thing that is slow for one, and GCD is so cheap. And before, why I'm trying to think why the complexity is just so much worse. Maybe it's just a cell pruning type thing. It's the GCD. I guess technically speaking, okay, I could buy that. What I was going to say is that technically speaking, the number of GCD is strictly less than the number of factors. I think that's why. Factors, because GCD going from right to left and then looking forward is always going to be decreasing, or well, increasing as you get fewer items. But that number of times of change has to be, because of the way that GCD is, it means that it has to divide by a number. And that number is going to make the constant way less than 128, which is the number of factors. Okay. I had to be better about this, I think. And it took 1.6 seconds, so it wasn't. So that means that in that way, because you can only you get a unique thing if the GCD is different, and the GCD is different if you divide it by a number. So that means that if you have all powers of 2s, that at most this will be, what is this, like 15 or something? So this only goes up, has 15 items at most, and that's the proof right there. So this is all of n time or of n space. This is all of n time. The thing is that ng will have to be log n, number of elements at most. So this is going to be n log n. I mean, instead of factor times n. Okay, I buy that. I am really not good at this today. It just reminded me of that bitwise OR thing, but I didn't really think about it in the same way. But it reminded me of one of the variation of that solution, of just, it's not quite like this, but the way that they did it have DP too, right? So maybe, can I rewrite this with DP? So I think there is one formulation that's kind of similar to this particular one, but there's also, yeah, maybe I can write it as a, I think the only annoying, now it's hard to write it as a, it's hard to write it as dynamic programming, and I think I tried to, but I just realized I forgot K, right? I think that's the similar idea, is that this statement is easy to write in an if statement, but not as easy, and because we do some deduping here. I don't know if I can do recursively. I think the idea was very similar to how I had it, but I was thinking in terms of factors instead of possible GCDs, but that's because factors allow me to do what I did in, did I submit that one? Maybe I didn't. No, I did. I guess why did I submit this one? I don't know. But yeah, I submitted this because I couldn't get the formula without using it this way. But the idea is very similar, even though you can't really finagle this. But the whole idea with constraining by login, I don't know. Anyway, that's all I have for today. That's all I have for this one. I'm going to go for my run. So yeah, thanks for watching. Stay good, stay healthy, to good mental health. Man, I'm so bad at this. I'll see y'all later and take care. Bye-bye.